Hello there and welcome back. Sorry I've not made and posted any videos for quite a while. Life got in the way, but as you can see I've been busy, still pootling around with electronics. I've made a few videos, but to be honest they've just been not very good. So hopefully I'll not be so pernickety about this one and post a bugger. Right. So on the bench we've got one monoblock that I made. It's one of two. It's a 120 watt valve amp using 6 EL34s, 2 EC99s or 12BH7s, and underneath this underneath this screen cap is a is it a 6 AU, what is it? I'm to try and remember. Come on, it says on the bloody thing 6 AU 6 WC. Yeah, anyway, we'll try and go into a bit more detail. Just give me a minute. Sorry, can't use a tripod as there's not much room. Right, what I'll do, I'll take the top off. Well actually, how am I going to film this? Let's see if I can film it. Right, there we go. So this is the 120 monoblock. The top comes off thus. There we go. So the amplifier, hold on, move everything out of the way. Quite heavy. Right, so this is the amplifier module, as it were, which has got a bit kinked, which is separate from the power supply. Now I basically had this idea and built an amplifier. It was in a case, and these like modules came out like, the idea was to build it like one of these Tektronix. This isn't a Tektronix scope. Get the plugger out. The idea was for it to slide out like that, and I built it up with two of those in. But the engineering, I mean, I've got a very simple tools, very simple workshop. The engineering, I couldn't get it accurate enough, and it was all squashed in, and it worked, and I wasn't happy with it, so I started again. So anyway, this is the amplifier module, as it were. So as you saw, we start off with, this is the 6 AU 6, that's right, so I keep forgetting, memory's not what it was. And so we start off with that, that's our input. The input comes in via this 3.5mm jack, as you can see winding underneath there, goes into this. Now this 6 AU6 is triode strapped, because it's a pentode, it's triode strapped, and it's driven from an active source for the anode load, which is basically a MGE 350 PMP transistor. Right, and then that goes into our two ECC 99s. They are parallel strapped. It's a bit of an overkill really for them to be like that, because just one would have done, but I'd already made the chassis, and so this sort of solution fitted, having two there. If I'd have just used one, I would have had an empty socket. So basically they are a long tail pair, sort of on steroids, to drive the 6 EL34s. So as you can see, this is our active anode load for the 6AU6, and this is a constant current source. I mean, that's a constant current source, they're both the same basically. This is a constant current source for the long tail pair. These resistors here, what are they? I'm just trying to think now. What are they? Long tail pair? Yeah, they're the anode resistors, and these are the coupling capacitors. This pot here is to balance either side. So if you look at the amp this way, we've got one side here, push pull, parallel, 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 push pull. I think that's how they the terminology. So this is like a bus, as it were, and that feeds the grid, the signal grid of each EL34. So there we go, connecting that. Right, I'm just having to try and think. Right, so that's all pretty simple. It's a pretty simple amplifier so far. I did have a little bit of a problem. These here are sense resistors, so basically it's running on fixed biased, and as I was saying, this pot basically, because it's a dual gang pot, it's feeding the negative bias to each of these buses, which obviously bias each EL34, which are, the pairs are matched within reason. So I can basically get that and null it using these two sockets here on the outside. There's a few other circuits here that I'll go into. This is basically a filter. So because I did have a problem with oscillation. Oscillation is a problem with these big powerful amplifiers. It does use quite a bit of negative feedback, so obviously there's a problem with oscillation. If it does start to run away, then this is just basically an RC filter. We'll clamp that at about 30 kilohertz. Is it 30 kilohertz, 35? I can't remember. I did write it all down, but I can't find the paperwork. Alright, yeah, that's one protection circuit. There's another protection circuit here. These are 3 1N4007 diodes, and they're reverse biased onto the anode. So if somebody was to power this amplifier up, turn the volume up without a load, they would clamp the output and stop it from going really high. What other protection circuits have we got? Right, on each cathode we've got this sense resistor. It's biased at about 30 milliamps. If the current rises through one of these valves or tubes, then obviously the voltage drop across this resistor will rise. So as you can see, there are wires going back from each cathode to this board here, and so any voltage rise goes through these resistors here, which are, where are they, 150 ohms, smoothed out by these caps, and then basically underneath there's a oh no, there you can see it there, there's a triac there, a C106D, there's a triac, and basically that turns on, energizes a relay, which I'll show you in a minute. That's in the power supply. That relay turns on and cuts the negative, or should I say the neutral supply, to the mains transformer, and the whole amp shuts down. When it does that, it lights an LED on the front of the amplifier to say we've got a fault situation, a flashing LED. Also on this board we've got a VU meter driver, which is this part of the circuit here, and this part of the circuit is the clipping indicator. There, what are they there for? Oh right, they're just there to, yeah, they're just there to filter the supply. those two big caps, and underneath there's a couple of Zenas to keep the rails at, I think, at about +12, -12. Also on here I've got these sodding great caps. Oh, what's that one? I can't remember. Oh right, that's 470U. That's decoupling for the first input stage. And this one here is a 220 microfarad, 220U. That's filtering for the long tail pair. These resistors here are just dropping the, because this runs on 450 volts, this is dropping the voltage to the input stage and to the long tail pair. This capacitor here is across the main capacitors, which I'll show you in a minute, in the power supply, as is this one. It's just there to cut down on any high frequency that gets into the power rail. As you can see, one last sort of note on the power supply, should I say. As you can see, we've got a big thick bus going down here, which is our ground, and this ground goes back to one point on the power supply to cut down on any hum issues. As you can see, our input stage is right at the end of this bus, and all our higher current circuits and stages are further along, ending up in this point here. Also connected to this point here is the output transformer ground. The only other thing I've noticed is the feedback resistor, which is underneath there, which you can't see. As you can see, I used a McMurdo what do you call it, connector to connect the power supply and the amp module. Right, let's go and have a look at the power supply. Okie doke, the power supply is underneath here. The whole thing is cased in this wooden box, chassis, wooden box in it. This took an eternity to build, basically because these were just big thick planks of sycamore, and I had to plane those down with how's that got on that? I had to plane those down with just a small wood plane. Got no workbench or anything, so it did take quite a while, and there's actually quite a lot to these because obviously we've got this sort of bit taken out here, there, all this was done with a chisel, and these are mitered joints. These actually took bloody ages to do, because to cut a 45-degree mitre with just nothing but an old Wilco saw, and then to try and play them so they were accurate and fitted, was quite a job. Right, let's turn it round. Right, looking at the front, I've just got a basically on-off switch, and these are the two LEDs that I mentioned. I can't remember which is which. One's a clipping indicator and the other one's a indicator to say that we've got a fault, and that is a VU meter-ish. It's basically just there for a bit of eye candy. Again, I had a problem when I wanted to come to do the scale, because these were just reading volts, up to 300 volts, and I tried hard to do a scale using bits of software. I tried to hand draw it and all the rest of it. In the end I thought, sod it, I'll just paint the bugger black, a bit like the switches on that spaceship in Douglas Adams' Hitchhiker's Guide to the Galaxy, where all the buttons and everything are black. But anyway, if the needle would have been was black, that would obviously be a bit too much, so I got some gold leaf and just put some gold leaf on the needle there. Lastly, There's a couple of lights in there to illuminate the front of it. One other thing I note on the front here is the control knob. I've had a bit of difficulty finding the right knob for the you know, to go with the amp. I would have preferred a brass one, but they're bloody expensive, so just got this nice aluminium milled one for the moment. It is heavy. That was the problem when I made the original amp. Both of these were in one unit and you could hardly lift the bloody thing. Right on the back, pretty simple. RCA in, fuse, main fuse, IEC power socket, banana jacks out. Right, let's have a look inside, shall we? Oh yeah, you probably did see a fan there. That's there to keep that chassis cool. That chassis gets hot enough to not exactly burn you, but it will hurt. So that fan on the other side that you saw is there to cool that down. This one, this little fan, is there to keep the power transformer cool, and it gets hot. You can hear the fans when you first power it up, but I'm looking to get some different ones. You can't hear it when the music's going, like, but right, here's the power supply and associated circuitry. Okay, so power comes in, mains power comes in into the on-off switch. Both neutral and live are switched. Right, as I said earlier, the neutral goes through this normally closed relay. That relay is opened if too much current is detected on any valve. So that cuts the neutral supply to the mains transformer. These mains transformer are overwound. They're 650, I think, at least VA, when 500 VA would have done. I wound these myself. I'll go into that in more detail in a minute. Yeah, so anyway, yeah, that comes into the power transformer. Right, the HT, the main B plus, are wound basically to save winding, lots and lots of windings. I wound two woundings side by side, bifilar wound, to get, I think it was something like 220 volts AC RMS windings. They then go through, I don't know if you can see down there, there's a couple of really big power resistors, and that is basically a soft sort circuit. This relay here engages and shorts those power resistors out after about 10 seconds. On this board here we've got three different circuits. On this side we've got a 6.3 volt DC power supply for the heaters of the input stage and the long tail pair. We've got a minus 100 volt bias supply, and it also powers the constant current source for the long tail pair. And lastly, this one is the delayed start. It's pretty easy, it's just an RC times constant, so basically this takes 10 seconds for this capacitor takes 10 seconds ish to charge this capacitor. When that's fully charged, power across this Zener down there is at a certain level where it engages this Donington transistor. That Donington transistor energizes the coil in the relay shorts out those two big power resistors down there. Over here we've got our main capacitor bank for the HDB plus. In all it's 1100 and something microfarads of capacitance. Basically there are four 820 microfarad caps and two 470 microfarad caps. They're basically in parallel together is 1100 something. As I said, this mains transformer has two high voltage secondaries, so each of those high voltage secondaries powers one half of this capacitor bank, should I say. I hope that makes sense. Obviously this is self-explanatory, these are all fused, so we've got fuses for the HT, fuses for the negative bias, fuses for the EL34 heaters, and that's a fuse for the 6.3 volt DC for the heaters. What do I want to show? Oh yeah, the heaters for the EL34s are running in series, so they're not at 6.3 volts, but they're at 3 times that, which is about 19 volts, I can't remember. So yeah, those EL34s are in series. What else have we got down here? We've also got a bit of protection in that we've got a Zobel network down there, which is that big resistor and that capacitor. That's to stop any oscillation, because basically this works fine, no oscillation with a dummy load, with just a purely resistive load. When you bung something like a speaker on there, it can oscillate, so that's to stop any funny business going off there. Just turn it around. Put you down a minute. Okay, over here we've got a switch mode, little switch mode power supply that powers the fans, and this power transformer here, this little one, that powers the supply for that protection board, BU meter board that I showed you, and it also used to power the relay, the power for the relay, which is about 50 volts AC, but it was getting really hot at that, even though it shouldn't in theory. If I remember rightly, this was working at 50 volts, 63 milliamps. So I mean, when that was rectified, that should have been enough to power that 45 volts 50 milliamps. It didn't, so I had to put another wind in on this. This amplifier has taken quite a while, because it's been put together, taken apart, put together, taken apart several times just to get things right. Last thing of note really, a couple of fuses down there for other things, like for the AC and for something else I can't remember. Another fuse on the DC there, big thick fuse holder, and lastly that's it. We've just got some big thick wires for output. I think that's all to say on there. What I'm going to do just to end the video is I'll just power them up on a dummy load, and you can see them working as it were.